Going live.
Wait, where's your cat?
What
Cat. I didn't have a cat.
This isn't live.
This is like.
Why are you throwing pencils at me? I don't need pencils.
Tan, is that your pencil? You want pencils?
Yeah, you can throw it in there. You can try and make it in there, or you can try and throw it at me.
Dan. Or you can do like.
It's up to you. But I do need them all back because we're running out. Whose pencil?
Pete X.
Who needs it?
Space. Pencil.
I'll probably have
All right. We're live. So now that we're live, I can say this. Let me get on camera. Happy birthday, Landry! Whoa! That's all I got.
Let's sing.
All right. 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear Landry. Happy birthday to you.
12-year-old man.
Oh man, I caught whatever Danny has. All right. Alrighty. So where we left off yesterday, we did the proof by contradiction worksheet, right? What? Yeah, that's when you're leaving. You check it and it puts in your time.
I turned that in.
You can do that or not. I don't care. And when you get back, hit the return. So this thing, we did this, right? We're done with it. I don't remember if this class got to know all the different signs for contradiction. Did I show you all the different signs? One of my favorites is lightning bolt. I don't know if I showed you that one. Lightning bolt with the dot. That's one of my favorites. I figured I forgot something. These are all the different symbols for absurd. You can do the interrobang, the X with 4 dots, this thing, absurd, lightning bolt exclamation point.
Why a lightning bolt?
Just because, why not?
I already turned that in.
Great. Not you, him. If you already turned it in, fine. I don't care. It's due next Friday, though. So let's get out our worksheet. I did give you the correct last page, correct? Did I or did I not? Okay. Alrighty. So what we're going to look at today is page 6, which is the angle bisector theorem. And really, it's not angle bisector theorem. It's really triangle angle bisector theorem. This really only applies to triangles, not just to any angle. So triangle angle bisector theorem. And the theorem states that if we have a Cevian that bisects an angle in a triangle, then the opposite sides of that, the two sides of that angle, will be in relationship the same way as the bases of that triangle. So x over y is going to equal a over b. Now, when you see something like this, you think proportion, you think similar triangles, right? And you're correct. There will be some similarity in play here. But it turns out there's no way to prove that these two are similar. They do have the same height, yes. So we would know their areas are proportional to the bases. That's not going to help us with the sides, right? So what we're going to have to do here is going to be kind of annoying, I'm sure, to you. But it's going to work. And that's what matters. So here's what I'm going to do. We don't have enough triangles to get the job done. So in this case, we're actually going to draw a line. So Luke, congrats. All right. And the line we're going to draw is going to be parallel to this line here. So I'm going to take out my straight edge. I'm going to draw a line that looks about parallel to that. Let's see, does that look parallel to this line here? Is that parallel? I'm going to draw it and you're going to hate it. So these lines are parallel, so says me. I created that. So let's call that line something. How about, I don't know, BQ. Right? We're going to do the proof on the next page. So I'm just drawing you the general idea right now. So you don't have to draw this if you don't want to. And then I'm going to extend this line.
Is that point Q?
And you'll notice now that we're going to have some vertical angles here, right?
What's the point at the bottom?
Q, I don't know. Let's call this X. You don't need to copy this down yet. I'm just showing you the general idea. So these two triangles we're going to prove similar. And then we're going to use the property of these parallel lines to get the rest done, more or less. All right, so let's flip it over. Let's take a gander at this.
What packet is this on the one?
This is number 7.
Yeah. If I turn the packet in, it's like that. Points.
What?
I already turned the packet in.
Why would you do that? It's not due this week. Go get it.
I turned everything in. I don't know.
Wait,
I don't
like the
understand
one
you
of
guys.
us?
I
Oh,
do not understand you.
All right.
All right, so for this one, what we're going to do is we're going to draw that parallel line, but it's going to be parallel to this guy. I think that'll be easiest. You could do the other one, but I'm going to do this. So these are parallel, so says me. I'll call this line, I don't know, CQ. Oh, that's going to be really close to the intersection point. Let's keep going. We'll call it CQ. And then we're going to extend this line. Until it intersects. Danny?
Fates.
And over here, and only one of them works.
Not cool.
I have fire back.
All right, so now that we've got this, let's write that down. So we said let C, let's call it, let CXQ exist. And then we're going to say we're going to extend ADX. Now remember, when two line segments share a point, that must mean they intersect there, right? So they would intersect at X. That's the whole point.
Why is there a dot next to X?
Because originally I was going to put Q there, but I thought it'd be too close. Yeah.
Why are we doing this again?
So we're extending this out so we have two triangles that we can get similar. And we're going to use their properties to prove that these go together. Okay? So these two triangles alone are not enough to get us that they are similar. So we had to add another one. So it tells you that we're given that AD bisects BAC. Well, if that's true, here's angle BAC, right? And AD bisects it. That means it cuts it into two equal pieces, right? Cool. So we're given that. All right. What do you see?
Shared side now.
Yeah, but we don't need shared sides because that's going to be a proportion of 1 to 1. And well, what we're trying to do is we're trying to get some of these triangles similar to this guy, right? Which is in vertical angles, yep. So by vertical angles theorem, we know that angle CDX congruent to angle ABD, or ADB, I should say. Thank you. Oh, man. Make sure I'm not leading you astray. Yeah, I'm feeling good about this. Sorry. I've been very sick today, so it's going to be hard for me to think and talk. What else do you see? It would help if I extended my parallels, right? Probably. But imagine I did, so I don't have to write it. Jess, what do you see? That's correct. So, we're stealing my pens. Yep, so these two angles are alternate interior, aren't they? Right? Does everybody see that these are alternate interior angles? Because we have two parallels cut by a transversal. So by alternate interior angles, right? They're interior because they're inside the parallels, right? And they're alternate because then they're opposite sides of the transversal. So by alternate interior angles theorem, angle XCD is congruent to angle ABD. Cool? So which triangles did we just prove similar? Bottom left or top?
What's the angle?
That one.
Alternate interior angles theorem.
Oh,
These two,
easy.
right? By angle, angle. So we know that these two are similar by angle, angle. So I'm going to write a little similar symbol so you don't forget that. By angle, angle similarity, we know we know that triangle ABD is similar to triangle. Well, A is a red angle, which means this angle must be red, right? We'll prove that by CSP later, so that's X. B is orange, so it's going to go with C. And then D is vertical, so it's going to go with itself.
Yo, big hits, man.
Chosen by CS.
And then by CSP, we're going to prove that these are both red, right? Let me zoom out. We're going to say that angle A, whatever it is, let's do DAB, must be congruent to angle. If we do DAB, it's third, first, second, right? So I go third, first, second here, DXC. And if you check, DXC is this angle. So we get that. Now, spoilers. Aren't these already alternate interior? Big transversal, right? But whatever. You can do it a lot faster just to get that. Because once we have this, what do we have? BC.
They're similar because same angles.
Yes. Now that we have this, what do you see? What's the big brain play? Because we want to connect this triangle to this triangle ultimately, right?
Oh, wait,
Check it out, guys. The big guy's an isosceles triangle. So that means the line we drew here between C and X must be congruent to AC. So by isosceles triangle theorem, these line segments are the same. You guys see that?
Would you just draw the first part?
By isosceles triangle theorem, because these two angles are the same. This big triangle,
Oh, alright.
two congruent sides.
Yeah,
Can you see what I'm writing?
Can you put it down now?
Okay. Reminds me of my dog. All right. I used to. Well, he said, could you put it down? My answer is yes, I could. I had to.
What kind?
Golden retriever. Red golden retriever. I rescued him from Hurricane Katrina. All right. Now check it out. If these two are the same, if this is length X, isn't this then also length X? It is, right? So I'm going to relate this X to this Y. Does that make sense? These two triangles are similar, so I'm going to relate them by CSP. So again, by CSP, I've got AB, otherwise known as Y, right? Look at AB, that's the first two, right? And I've got XC, otherwise known as X, the first two, right? So I've got AB over XC. Andre, turn it down, please. Turn it down. You need one of these?
Huh?
You need one of these?
Should throw it back.
See if I've got an extra of a small packet. I don't. Give you a thick one. So we know AB over XC would relate to BD over CD. We're on page 7. AD over XD. Look how happy he looks. All right, now again, we wanted to get X, Y, and A and B together. So let's substitute little letters. Isn't X the same thing as XC? Right? So this implies X is the same thing as XC. And AB, well, AB is the same thing as Y.
What? Wait. How?
AB, same thing as Y.
Oh, there's two.
XC is the same thing as a little x. Yep.
There's two ABs.
Yeah, my bad. BD, same thing as little b.
Oh, because they're capital.
CD, same thing as little a. Now, I could keep going, but I don't care, right? I've got what I want. And now what do I do to get it to match that? Flip. Yep. Therefore, x over y equals a over b. Now, we talked about how to make this proof a lot shorter, right? What you do is you get these two angles right off the bat, alternate interior. And then you've got isosceles, and then you're good. So we didn't need this. We didn't need this, but we were going to use alternate interior for these guys, the red angles, right? So we'd have used alternate interior for these angles instead of using CSP. And then we would have done double A. And then when we would have done this and gone on. So we didn't need the vertical. Turns out the vertical, true but not helpful, right? We already had enough information. And alternate interior, we could have just gotten these two. Which is why I asked Jess which one she was seeing. Were you seeing these two, or did I lock you into that? Okay. I didn't want to steer you into it, but I wanted to show that that's the thing you're going to think of on your quiz, and then you're going to get stuck and think, wait, what? You have to see that these are alternate interior, right? You have to. So don't just think, oh yeah, it's something with alternate interior, and then you see this and you think, well, that doesn't help me, right?
I'm gonna lose points.
There's another set of alternate interior. If you do more, that's fine. I don't care.
What if I extend a triangle and add another triangle I didn't need to?
Say again?
What if I add another triangle to get the answer and I didn't need to, but I
That's
still got
fine.
the answer?
I don't care if you do more. But alternate interior, isosceles triangle, CSP, or double A similarity, then CSP to get X, Y, A, and B together. Cool?
Makes sense.
So it ends up working. It's a really bizarre thing, but it's true. So, how do we feel about that last one before I go on? We feeling okay? All right. Well, last thing we have to do in this packet before I add on to it on Monday is we're going to prove that these angle bisectors are all concurrent. Okay? And the question is, do I want to move on to that now or do I want to wait? First hour is a class period behind because of how the schedule's worked out. Let me think. Or do I save my voice for my other classes? Oh, do you need the new version? The version that doesn't look dumb? Okay. All right, being a good neighbor.
Oh, I have the one that's.
You have the old version?
AD.
Yeah, there you go. If you have the one that says AD everywhere, it's because my computer crashed in the middle of making it, and I thought, actually, it didn't crash in the middle of making it. It crashed right after I made it. And I thought that it auto-saved the whole thing, because I looked over and it's like, oh, looks good, right? It didn't. It auto-saved in the middle of that, working on that last problem. And I had the template down, but didn't change the stuff. So I had like G here and another Y there, and these were all 80s. All right, so let's just take a look at this before I decide to get into it or not. They tell you that these are all angle bisectors, right? So if we know that these are all angle bisectors, what can we add to our diagram?
The congruent.
A lot of congruent angles, right? So if this is an angle bisector, then this is true. And this is true. I'm using double bars now because some of you guys are using single bars when you aren't using color. Not a good way to do proofs, guys.
Does that mean?
I'm saying that if you're going to not use color, you have to use multiple bars.
I know. I think I did.
Because if you don't, then it's going to look like all these angles are congruent, and they're not, right?
I think I did. That made sense.
Hot. Very hot. I burned myself in the first hour and had to spit it out on the table. Yep.
Isn't that worse?
Wasn't on. I didn't record it, unfortunately. I know. But if I said I did, you go back and watch and actually learn. All right. So we're going to prove that these lines are concurrent. Now, by definition, aren't all of these lines Cevians? Okay. So we're going to say by definition. Let's go AE, BF, and CD are concurrent. Oh, sorry, not concurrent. Sorry, not are concurrent. Are Cevians. We're trying to prove they're concurrent. Told you guys, I'm not on my A game today. Between you and me, I haven't been on my A game all year. The best I've ever reached is a B game. Excited for next year. Also, I'm gonna miss you guys so much.
You need to stay
So much.
Don't make me get emotional.
I'll be in here next year.
Don't make me get emotional.
Think about it all the time. All right. For real? Oh, that sucks, man. So. You ever consider like orthotics or like platform shoes? What?
I saw you pose junior.
Mr. Mackey,
That's
you
good.
got a horn.
Funniest kid in this class right now.
I call my dad.
All right. That's great.
He's my older brothers and
All right, so we know these are Cevians, which means by Ceva's theorem, how they divide up the triangle should all multiply to what? By Ceva's theorem. A over B, C over D, E over F should all multiply to what? 1, right? By Ceva's theorem. And we're allowed to use that because they're Cevians, right? So, by Ceva's theorem, oh, hold on. What's the other thing we need for Ceva's theorem? Sorry, guys, I'm not thinking my best today. What's the 2 things we need for Ceva's theorem? We have to have Cevians, and they have to be what? They have to be what? No. You're filling in what I need to do before I get there. Ceva's theorem says what? Go back to Ceva's theorem. What does it say?
Mike, I need to do that.
For Ceva's theorem, what does it say?
He's not that like.
You need to prove that they're concurrent, exactly.
He's not the cold nose.
So bummer. I'm all over the place. We're going to use Ceva's theorem converse to bring it home right at the end. So we can't do this. Sorry. I didn't do this first hour because we didn't get this far. So I'm a little off track of where I should be. I've got lots of cough medicine in me. It's going to be a fun class. Yeah, probably extreme amounts of alcohol. All right. Right?
Have Bartos bring the bread one time.
Oh, yeah, exactly, right. Okay, so how are we doing on time? Should I try to salvage this or should I just leave it? Yeah, in about 9 minutes. All right. So what we're going to do is we're going to use that property with the same heights, right, to get their areas all similar. And that's going to prove that A, B, C, D, E, and F equal 1, and then by Ceva's theorem converse, they must be concurrent, right? So if you want, for self-development for Monday, if you can get this done before Monday hits, I'll give you some self-development points. Generally, this is the concept. We're going to use that these guys have the same height, right? And these guys have the same height to say their areas are proportional to their bases. Subtract and get this, right? And then we're going to do same dumb logic. Cross things out. Therefore, A over B, C over D, E over F, it's multiplied together equals 1. And then by Ceva's theorem converse, if that's true, then they must be concurrent. Does that make sense? That's it. That's it. It's literally all we've been doing this week, all at once, right? That's literally it. Proving angle bisectors concurrent is very easy.
Both sides not, it's algebra, not challenge.
Both sides. That's basically it. Next week, I'm hoping to run through this really quickly and get to the ones that aren't quite as easy to do, right? For instance,
Ask Mr. Mackey.
How you spell it?
Remember we get bullied in Snapchat thing too?
Oh,
orthogonal. See, orthogonal. Cevian or no? Cevian or no?
No,
You can't even remember.
no, it's not. I forget that.
Vertex opposite side is
Oh,
Cevian.
for that.
Yes, yes.
Yep, Cevian. So by Ceva's converse, right, we can prove the same way we do this.
Alpha.
Yeah, but I'm saying after you put AO,
You know what?
you
Same
put
thing.
alpha for that.
What line segment is this?
What? Oh,
Median, right? And is a median a Cevian? Yeah, it goes vertex opposite side. So again, same proof for the angle bisectors that we just did. The one thing we have to worry about is when we have this going on, perpendicular bisector, right? Is that a Cevian? Yes, go. It's not in here. Not a Cevian, right? And so we're gonna need to come up with a more clever way to do something like this. Question is, can we even actually? Well, we should investigate first.
Good idea, man.
Oh, he said like grade in math.
Yes.
What is it? All I have to do is triangle ADE.
I literally have all these scores and they're great.
You got the angle. Did you show the relationship? The relationship's not 1-to-1. It is if you do that to that. But is that part of a triangle?
Or the hard math is easy.
This right here is part of a triangle. No, this is, right? There's the relationship you need.
There's so many.
I know.